Here we have a table of values, and we want to determine, does this table of values represent a linear or quadratic equation? It's one of the two. And then once we determine that, find the equation of the curve. Curve is general in math. It could be linear and still be called the curve. So first, let's determine if it's linear or quadratic. So if I find the differences on the left of the x values, we see that all the differences are 1. If I find the differences for the y values, 13 minus 6 is 7. 6 minus 5 is 1. 5 minus 10 is negative 5. And 10 minus 21 is negative 11. If this was a linear equation, I would have a common difference, which would tell me the slope. Okay, I don't have a common difference. It's not linear. So let's see if it's quadratic. So I'm going to find my differences again. 7 minus 1 is 6. 1 minus negative 5 is 6. Negative 5 minus negative 11 is 6. I found that the second level of differences is a common difference of 6. So this is going to be a quadratic equation. So next we're going to find the equation for the quadratic representing the data. So we're going to use the general quadratic equation, and we're going to solve for the coefficients A, B, and C, and then we'll have our quadratic. So we're going to do this by plugging in points and solving equations. Now, the first point that I'm going to start with is the point where x is 0, which means this is the y-intercept. So I'm going to plug that into my equation. So y equals 5 and x equals 0. This is going to help me find the coefficients A, B, and C. Now, I like plugging in x equals 0 because when I multiply by 0, this equals 0 and this equals 0. So I have just found the value of one of my coefficients. So C is equal to 5. So here's what I know so far. I don't know A, I don't know B, but I do know C equals 5. So now I'm going to plug in another set of points. So I'm going to plug in 1, 6. I don't really like plugging in negative numbers. So 6 is equal to A plus B plus 5. I'm going to subtract 5 from both sides, which gives me the equation 1 is equal to A plus B. I have 2 unknowns. So if I want to solve this using my system of linear equations, if I have 2 unknowns, I'm going to need to have 2 equations, 2 variables, 2 equations. So now I'm going to plug in, I'm going to go back to the original equation, and I'm going to plug in the point 2, 13. Okay, I'm going to clean that up and move the 5 to the other side. So now I have 2 equations and 2 unknowns. I notice before I put them together, here I know that I can either multiply both sides or divide both sides by a common number. So I notice that all of these are even numbers. I'm going to divide both sides by 2, and then I'm going to bring my equations together. Okay, I don't know if that helps, but I brought the numbers down. So I'm going to bring both equations together, and I'm going to solve using the elimination method. So to solve using the elimination method, I need to pick a variable. So I'm going to pick the variable B, and in order to solve, I need to multiply both sides by -1. That way I will have a -1b and a +1b, so that when I add down, the b's will cancel. So the top equation becomes -1 is equal to -a minus b. Okay, add down, and I get a equals 3. So I have C, I have A, Next, I need to solve for B. So I'm going to plug A into that equation. Solve for B. B is equal to -2. So now I have my equation. Plug them back into the standard form for the quadratic equation. A is 3, B is -2, and C is 5. Now let's go back to our table. Y is equal to 3x squared minus 2x plus 5. Now we notice something interesting. A turned out to be half of the second level common difference, which is very interesting, but that'll be a discussion for another day.